my name is Zach. In this video, we'll be going over matter and change. To start off, matter is anything that occupies space and has mass. It is all around us, made of atoms, the building blocks of life. Each atom has its own chemical identity. There are two main parts of the atom. There are the electrons that are contained within the outer rings, and there are the protons and neutrons that are contained in the nucleus. Each element will consist of an atomic number, which is the amount of protons, the mass number, which represents the molar mass. There will be a specific amount of protons for each element that will not change or vary, but the neutrons may differ, making there being different isotopes. The molar mass will be different for each isotope depending on the neutrons being different for each one. But on the periodic table, there is one molar mass because of the existing isotopes averaged into one. Each element on the periodic table will have its own symbol to represent the element. For example, H is hydrogen, Na is sodium, and Fe is iron. This will be for every element in the periodic table. Each element will have its own symbol. Each element is grouped into columns where they are shared with the same valence electrons. For example, the elements in the first row all have one valence electron. There are 7 main groups within the elements as well, which are the nonmetals, alkali metals, transition metals, alkali earth metals, halogens, noble gases, and rare earth metals. Any measurable characteristic whose value describes the condition of a physical system is referred to as a physical property. A system transitions between fleeting states can be described by changes in its physical attributes. Observables are a term used to describe physical characteristics. These attributes are not model. Examples can be color, density, hardness, and melting, and boiling points. A chemical property is any of a material's properties that becomes evident during or after a chemical reaction. That is, any quality that can be established only by changing a substance's chemical identity. Examples of chemical properties include flammability, toxicity, acidity, and reactivity. There are more shown on this slide. Compounds and elements can go through chemical changes and physical changes. Chemical changes break down into 2 or more separate molecules, occurring when one material reacts with another to create a new substance. These processes are referred to as chemical reactions, and they often cannot be reversed except by other chemical reactions. We do this in our everyday lives. Burning, cooking, rusting, and rotting are examples of chemical changes. Physical changes include transitions from one state to another, such as from solid to liquid or liquid to gas. Cutting, bending, dissolving, freezing, boiling, and melting are some of the processes that create physical changes. Crushing a can, melting an ice cube, boiling water, mixing in sand, breaking glass, dissolving sugar, and water are all examples of physical changes as well. For example, glucose and oxygen create 2 new reactions, which are carbon dioxide and water, which is CO2 and H2O. Remember, for each equation, it must be balanced, just like in this equation right here. For our next example, the 2 substances baking soda and vinegar create 3 new reactions, which are water, sodium acetate, and carbon dioxide, which is CHO, H2O, and CO2. For our next part of this, we're going to be going over classifications of matter. We will be going over pure elements, compounds, heterogeneous mixtures, and solutions. The first part of this will be the pure elements. To start off, in chemistry, a pure element means a substance whose atoms all, or in practice almost all, have the same atomic number or number of protons. Nuclear scientists, however, define a pure element as one that consists of only one stable isotope. Let's start off with carbon. Carbon is classified as a pure element because life needs carbon to exist. This is due to the fact that it may create a large range of chains with various lengths. It was formerly believed that living things were the only source of the carbon-based chemicals that make up life. They were believed to have a spark of life. A few physical properties of carbon would be its color and nature. Its color is black or dull gray, and its nature is soft and pretty delicate. It has an atomic number, atomic mass, and electronegativity. This will be its atomic number is 6, atomic mass is 12.011, and electronegativity of carbon is 2.5. The word carbo, which means coal, is where carbon derives its name from. Carbon makes up 0.032% of the Earth's lithosphere, which is the crust and outer mantle by weight, according to the Encyclopedia of Earth. Now for carbon. Carbon is also a pure element, because the majority of copper is used in the electrical equipment like wiring and motors. This is due to the fact that it conducts both heat and electricity extremely well and can be drawn into wires. It is also used in construction, such as roofing and plumbing, and industrial machinery, such as heat exchangers. Some of its physical properties would be its reddish-brown metal with exceptional viability and ductility. A few chemical properties would be its atomic weight, atomic number, and atomic mass, which would be its atomic weight is 63.54, atomic number 29, and its density, aka its mass, is 8.94 grams per centimeters. Copper was used by ancient people and is one of the most handful of metals found in its native form. In 1857, the largest single piece of copper weighed around 420 metric tons. For silver, this is a pure element because it's used in the production of jewelry and silver tableware, where its appearance is important. Silver used to make mirrors because it is visible light reflector known, though it tarnishes over time. Dental alloys, solder, and brazing alloys, electrical contacts, and batteries are also made from it. A few physical properties of silver is white, glossy, soft, and ductile metal. It is excellent heat and electrical conductor. Despite having the best electrical conductivity of any metal, we are unable to use it in all electrical appliances due to its high price. For chemical properties, it has an atomic number 47, atomic mass of 107.87 grams per mole, and its electronegativity is 1.9. Silver is said to be the most reflective metal and has the highest thermal conductivity of any element. Now for the compounds. Compounds can be created if two or more elements were to be combined. Take water as an example. It has 2 hydrogen atoms and 1 oxygen atom. These make up a compound. As for salt, salt is a compound as well. It consists of 2 elements, sodium and chloride. Neither elements occur separately and free in nature, but are found bound together as the compound sodium chloride. Here are a few physical properties. They are brittle, most soluble in water, and other polar solvents. Can be acid or basic or neutral. Can conduct electricity and have high melting points. It melts at 801 Celsius and begins to vaporize at temperatures just slightly above this boiling point of 1413 Celsius. Some fun facts about salt is that our body needs 100 grams of salt for every 40 kilos of weight, and sweat contains between 2.25 and 3 grams of salt per liter. Now for water. As I mentioned earlier, for my first example, when introducing compounds, water has 2 hydrogen atoms and 1 oxygen atom to make it up. Water atoms don't actually exist. The ratio of 2 hydrogen atoms to 1 oxygen atom determines the composition of water molecules. Water has specific heat. Water in a pure state has a neutral pH, and water conducts heat more easily than any liquid except mercury. And here are some of its chemical properties, which is chemical formula H2O. Molar mass is 18.01528 grams per mole, and has no odor, aka no smell. So here's some fun facts about water. Water is nearly 90% of Earth's water, while most of it is salty, while the rest is drinkable. Also, most fresh water is also in ice. And for this last part in the compound section, let's talk about sugar. Sugar is a compound because it's formed by a combination of 3 atoms, carbon, hydrogen, and oxygen. Since these 3 atoms are chemically joined with each other, thus they form a compound in nature. Some of its physical properties of sugar is sweet taste, color development, and surface texture. Here are some of its chemical properties. It has a chemical formula of C12H22O11, has a molar mass of 342.30 grams per mole, and has a density, aka mass, of 1.587 grams per centimeters. Sugar is found in all plants as well. Sugar has been around for around 10,000 years, and it does not spoil. Let's go over the heterogeneous mixtures. just like the one shown on the screen, like pizza, chocolate chip cookies, sandwich, salad, and a soda with ice. But I'll be only going over 3 of them. For the sandwich, it is a heterogeneous mixture because it's a mixture of different parts and is easily distinguished like a salad, bread, and meat altogether. For its physical properties, it has a brown color to the outside of it, is pretty soft, and is 250 grams. Some of its chemical properties of the sandwich is that it won't rust, won't explode, and can burn. Some fun facts about this substance is that John Montagu, who started a craze for eating beef between the 2 slices of toast, was named after him. The first recorded use of the word sandwich with a capital S was in 1762 by Edward Gibbon, writing of the Beef Steak Club in London. Chocolate chip cookie is part of this because it's an illustration of the heterogeneous mixture since it contains many materials that are distinct from one another. There is an uneven distribution of the mixture in chocolate chip cookies. As a result, the chocolate chip cookie serves as an illustration of heterogeneous composition. Some physical properties of this is the shape of the cookie depends on how well your dough ball is. The texture has hard edges and a soft chewy middle. The phase of it goes from a round dough ball to a cookie. For its chemical properties, the baking soda in the cookie can decompose and make the cookies moldy. Flour contains proteins referred as the gluten as well. The chemistry behind the baking soda is that chemical reactions with brown sugar, cocoa, and chocolate. Some fun facts about this is that they were invented actually in an accident and were popular during World War II. For soda with ice, it has 2 components, one in the liquid phase and one in the solid phase, which is the ice and the liquid, aka the soda. Some physical properties of the soda is that the color of the soda doesn't change and the ice slowly changes color depending on the soda. Some of the chemical properties are soda with ice reacting with Mentos. Some fun facts are that 1 of every 4 beverages consumed in America today is a soft drink. The average child drinks over 500 cans of soda a year. Soda leaches calcium from bones, an alarming fact since it's reaching epidemic proportions. And that's about it. I think I've gone over this matter and change video, and thanks for watching.